to look normal distribution, which is the heart of statistics. Myself, M.Lakshmi, Assistant Professor, Department of Mathematics. In this session, we are going to discuss about the definition of normal distribution, properties of normal distribution, the transformation of normal distribution to standard normal distribution, and we are going to solve some problems in normal distribution. So the definition of normal distribution: a continuous random variable x is said to follow the normal distribution with parameters mean and variance. Mean is denoted as mu and the variance is denoted as sigma square. And the probability density function is defined as f of x is equal to 1 upon sigma square root of 2 pi e power minus of x minus mu the whole square divided by 2 into sigma, where the value of the range of x is from minus infinity to minus infinity to plus infinity, and the range of mu is also from minus infinity to plus infinity. Sigma is always greater than 0. So this is the representation of normal distribution. We can represent the normal distribution as x follows the normal distribution with the mean and the variance. Next, we are going to see the properties of normal distribution. The normal distribution curve is a bell-shaped curve which is symmetric about the mean. In normal distribution, the mean, median and mode all are equal. Only in normal distribution it is equal. In normal distribution, the single peak point is there, so it is a distribution of unimodal. So sometimes they will ask you in the question, normal distribution is a bell-shaped curve which is symmetric about x-axis and it is a unimodal. So this is and next we are going to see the property as, and these three values you have to memorize this. These are all the standard values. These three values are the standard values. So this is a normal curve. So this is the normal curve which is in bell shape, and this is the center line is your mean. So in general we will denote it as mean as mu, and this is in left hand side it is your minus. The central line denotes the mean. Left hand side is your mu minus sigma. Your right hand side will denote the mu plus sigma. So the probability of this region is given as, this is approximately equal to 68%. These are all the standard values. The probability of in normal distribution also we will see later, and the probability of the next distribution is probability of mu minus 2 sigma less than x less than mu plus 2 sigma. The value of this is 95.44%, or we can write it as 0.9544. Similarly, the probability of mu minus 3 sigma less than x less than mu plus 3 sigma is also equal to 99.73%. These three probabilities or the standard probabilities you have to memorize this. Next property is total area, that is normal curve. Total area of the probability is equal to 1. So total area under the normal curve is 1. So here in left hand side we will take it as minus infinity to plus infinity. The center is the mean. So the probability of minus infinity less than x less than infinity is 1. So left hand side, so off of the, since the property is symmetric, left hand side of the probability is 0.5. Likewise right hand side of the probability is 0.5. That is, we will write it as, we can write when probability if x is less than mu is also 1 by 2, or the probability of x is greater than mu is also 0.5. That is how we can write this probability of x less than mu. How we can write this as probability of, like this also we can write probability of minus infinity less than x less than mu. Like that, how we can write the probability of x greater than mu as probability of mu less than x less than infinity. Since it is symmetric, left hand side is also, the probability is 0.5, right hand side the probability is also 0.5, total probability is plus 1. And the next property is the limiting case, that is normal distribution is the limiting case of binomial distribution. Is nothing but normal distribution is the approximation of binomial distribution when n is very large. So these are the important concept you have to learn. That is expectation of ax plus b is how we can write this as a into expectation of x plus b, which means expectation of the constant term is constant, whereas what is the variance of ax plus b is a square into variance of x, but in variance of the constant term is 0. So next we are going to transform the normal distribution into standard normal distribution by substituting z. We are going to take z is equal to x minus mu bar by sigma. So we are going to transform the normal distribution into standard normal distribution by taking z is equal to x minus mu by sigma. So we are going to take z is equal to x minus mu by sigma. If we take this, the normal distribution is transformed into standard normal distribution with mean 0 and variance 1. So if we take expectation on both sides, so expectation of z, how we can write here as expectation of, if you separate this, how we can write this as 1 by sigma into expectation of x minus expectation of mu by sigma, or you can write it as 1 by sigma into expectation of mu. So the expectation of the constant term is constant. So 1 by sigma, what is the expectation of x? We will denote the mu as a mean. The expectation of x is nothing but mean. So instead of expectation of x, we can substitute mu. So mu by sigma, here expectation of the constant term is constant term. Here we will write it as mu by sigma. So mu by sigma minus mu by sigma, the variance will become 0. So we are transforming the normal distribution into standard normal distribution by taking the value z is equal to x minus mu by sigma. So similarly we can find the variance for this. So variance of z. So variance of z is equal to, if you take variance, so the constant variance of ax is a square into x. Here the constant is sigma, so you will get 1 by sigma square into variance of x. The constant of variance of the constant term, that is variance of mu by sigma is 0. So this is your variance. So which is equal to, so what is the variance of the normal distribution is? Variance of the normal distribution is sigma square. Instead of variance of x, we can substitute sigma square. So the variance in standard normal distribution, the variance will become 1. So we are transforming the normal distribution into standard normal distribution with mean 0 and variance 1. So likewise, what is the probability density function of normal distribution is 1 upon sigma square root of 2 pi e power minus of x minus mu the whole square divided by 2 into sigma square you know the ranges of x and mu. X varies from minus infinity to plus infinity, mu varies from minus infinity to plus infinity, and the value of sigma should be greater than 0. So in this, if you substitute, instead of mean, if you substitute 0, it will become x square in numerator. Likewise in denominator, instead of variance, we have to substitute 1. So this transformation, so here is also standard deviation is there. So instead of standard deviation, variance is 1, in normal distribution means standard deviation is also 1. So we are transforming, that is we are transforming the normal distribution into standard normal distribution. How you will get the PDF? Probability density function is 1 by square root of 2 pi e power minus x square by 2. That is we are transforming. So we have to write this as f of z is equal to 1 upon square root of 2 pi e power minus z square by 2. So this is the probability density function of the standard normal distribution. Next, we are going to solve the problems. The first problem is, what is given here is x is a normal variate. Here mean is given as so in the first problem, we are having two normal variables, is it? X and y are two normal random variable. In both they have given the mean and variance. So we are going to differentiate. So the mean of x, we are going to denote it as mu x. Mean is given as 1 in the x random variable, and the variance is given. That is variance, we are going to denote it as sigma x square. Variance is given as 4. Likewise, in y, what is the mean is given? The mean of y is given as 2 and the variance of y is given as 3. What we have to calculate? We have to calculate the distribution of, we are going to calculate the distribution of x plus 2y. To define the distribution, we have to find the expectation and the variance of the distribution. And what they have mentioned here is independent of x. Y is independent of x. If x and y are independent, we can write the expectation of x plus y, we can write it as expectation of x plus expectation of y. Since x and y are independent, we are going to write the expectation of, because we are going to define the distribution for x plus 2y. So we have to find the expectation of x plus 2y as well as we have to find the variance of x plus 2y. So what we'll have here, expectation of x plus 2 into expectation of y. The expectation of x is nothing but mu of x. This is nothing but mu of x. And similarly, expectation of y is nothing but mu y. So which is equal to, what is the value of the expectation of x is 1 plus the value of expectation of y is 2 into 2. So you will get the mean value as, what is the mean value is 4. Similarly, we have to calculate, to distribute the distribution, to define the distribution, we have to find the variance of x plus 2y. So which is equal to variance of x. We have to write the constant of variance of 2y. We have to write it as 2 square into variance of y. We know the variance of x value as well as the variance of y value. They have given in the problem itself. Variance of x is 4. So we have to write as 4 plus 2 square is 4. And what is the value of variance of y is 3. So what is the variance of x plus y is 16. So we are going to write the distribution. So the distribution of x plus 2y follows the normal distribution with the mean. What is the mean is 5 and the variance is 16. So that's all. This is the solution for the first problem. Next we are going to see the second problem. So in second problem also we are going to define the distribution, but in this problem we have defined y. So that y is equal to 1 by 2 of x minus 1. So in general, they have defined only X random variable. So we can take this as the mu as mean. What is the mean is 2, or we can write it as expectation of X. Mean we can denote it as E of X, or X bar also we can denote the mean as X bar also, but in normal distribution we will denote it as mu. So expectation of X is 2, and what is the standard deviation they have defined here? What is the standard deviation is 3, but we need the variance value also. So variance is nothing but square of the standard deviation. So what is the sigma square is equal to 9. Now we are going to define the distribution. What is given? Y is equal to 1 by 2x plus minus 1 is given. Just we are going to take the expectation and the variance. So what is the expectation of y is? Nothing but 1 by 2 into expectation of x minus expectation of the constant term is the constant term. So which is equal to 1 by 2. What is the expectation they have given here is 2. So 2 into 2. 1 by 2 of 2, so we can cancel this 2. What is the value is 1 minus 1. So in this, what is the mean of y is 0. Is it? Then we have to calculate the variance of y. That is the variance of here. The y is 1 by 2x minus 1. So if you find the variance for this, you will get the constant will become 1 by 2 the whole square. So directly we can write it as 1 by 4, and variance of x. What is the variance of x? We know the variance of x is 9. So you will get 9 by 4. So how we can write the distribution here as y follows the normal. Y follows the normal distribution. What is the mean is? Mean is 0, and what is the variance is? 9 by 4. So in this problem, just they ask you to define the distribution. So next problem they asked in GATE exam. So what is given is, let x be a normal random variable. In this, the mean is given as, what is the mean is given as mu 0. What is the mean is given as 0? We can take it as mu. First we will write what is given, what we have to find. So what is given is, mu is given as 0, and the variance is given. We can take it as sigma square as 9. If we need, we can find the standard deviation also. Standard deviation is nothing but square root of variance. So sigma is 3, and one more is also given, the probability of x. When probability of x is greater than 3, what is they have defined in the question itself? They have defined it as a. What we have to find is, we have to find the probability of modulus of x less than or equal to 3. So we have to find the probability for this. So to find the probability of modulus of x less than or equal to 3, how we can write this? This is nothing but probability of minus 3 less than x less than. Since it is given as equal to, we can write it as equal to. So in continuous distribution, strictly less than, or we can write it as less than or equal to, there won't be any changes in value. Only in discrete random variable it will change. So in continuous random variable, whether it is a strictly or less than or equal to, the value remains the same. So we have to find the value for probability of modulus of x less than or equal to 3. This is nothing but probability of, we have to find the probability of minus 3 less than or equal to x less than or equal to minus 3. So for this, I am going to draw the normal distribution. So this is a normal distribution in this problem. So this is not the standard normal distribution. In standard normal distribution, the mean is 0 and the value of variance is 1. So this is not the standard normal distribution. But the mean, they have given the value of mean as 0, and what is the variance is. So that in right hand side, Here you will have 3, left hand side you will have minus 3, and this it goes on left hand side as well as in right hand side it goes on. So the value is minus infinity to plus infinity. At the last we can consider it as minus infinity to plus infinity. So we have to find the value for probability of minus 3 less than or equal to x less than or equal to 3. To write the value, we know that the sum of the probability, that is the total area under the normal curve is 1. Total area, we know that total area under the normal curve is 1. So how we can write it as probability of minus infinity? Since they have given it as a less than or equal to, we can consider it as less than or equal to x less than or equal to infinity. The value is 1. So from minus infinity to plus infinity, the probability of the normal curve is 1. Just we are going to rewrite this. How we can rewrite this as probability of minus 1 to minus 3. So we are going to rewrite it as probability of minus infinity less than x less than minus 3 plus, and from minus 3 to plus 3, is it? We are going to split this minus infinity to minus 3 and minus 3 to plus 3, and again we are going to write this as 3 to plus infinity. We are going to rewrite this, that is from minus infinity to plus infinity. We know the probability is 1. We are rewriting this. So probability of minus 3 less than, since it is given as less than or equal to, we can write it as less than or equal to minus 3 less than or equal to x less than or equal to 3 plus probability of 3 less than or equal to x less than or equal to infinity, which is equal to 1. So what is given? They have given the probability of, what is given here is probability of x greater than or equal to 3 is given as a. Is it? That is probability of x greater than or equal to. So this region is given. This region is nothing but probability of 3 less than x less than infinity. So this value is given as a by symmetric property. Since the normal distribution is a symmetric property, it satisfies the symmetric property. The value of minus infinity to minus 3 is also a. So we can write it as a plus probability of minus 3 less than or equal to x less than or equal to 3 plus this is given as a, which is equal to a. So what is the value of probability of minus 3 less than or equal to x less than or equal to 3 is equal to a plus a is 2a. So if we bring that to the right hand side, it will become 1 minus 2a. So the option is, the third option for this problem, option is 3. Next we are going to see the next problem. So what is the fourth problem is? A random variable x has a normal distribution. In this problem also they have given the mean. They have given the mean as mu is equal to 100, and they have given the probability of x less than 120. They have defined it as alpha. Is it? Which means we are going to draw in the normal curve. Here the mean is given as 100. Is it? The central line they have given is at 100, and they have given the probability for 100 to 120. They have given the probability. So right hand side we are going to take it as 120, 110. So the probability of this region is given as alpha. Is it? So what about your left hand side? So here also if 100 plus 20 is 120, what is the value in your left hand side is 100 minus 20. Here you will have 80. So what is since it is a symmetric distribution, the value of probability of 80 less than x less than 100 is also equal to alpha. We have to find the probability when x is less than 80. So in this region we are going to find the value. We are going to find the probability for this region. When probability of x is less than 80, we are going to find the probability. So how we can rewrite this? Probability of x is less than 80. In this region we are going to find the probability. How we can rewrite this as probability of minus infinity less than x less than 100 minus probability of 80 less than x less than 100. To find the probability for this region, what we are going to do is, we are going to find the probability is from minus infinity to 100. If you subtract this region, you will get the value for this region. So we know the left hand side, the probability of a left hand side is 0.5. Already we have explained here. So minus, in this itself they have defined the probability of 80 less than x less than 100 is equal to alpha. So your answer is 0.5 minus alpha, but we don't have option here. But how we can write, we got the answer as 0.5 minus alpha. Here how we can write the 0.5 as 1 by 2 minus alpha. So 1 by 2 minus alpha option is also not there, so we can take LCM. So how we can write this as 1 minus 2 alpha divided by 2. So the option for this fourth problem is 1 minus 2 alpha divided by 2. This is your fourth option. So next problem, say in normal distribution, mostly the table value, if in problem, if we need the table value, in problem itself they will give the table value. So if it is not required, they won't give the normal table value. So in this problem, so what is the problem given here is, a normalized bank has found that the daily balance available in its savings accounts follows a normal distribution with a mean of rupees 500. The mean value of mean is given as 500 and the standard deviation is given as 50. We are not going to solve this just by using the normal curve diagram. We are going to write the value for this. So what we are going to find is the percentage of a savings account holder who maintain an average daily balance more than, what is given here, more than 500. So the account holder, those who are maintaining the balance more than 500, we are going to find the probability. Is it? In this problem, the mean value is given as 500. So what we have to find? We have to find the probability, the account holder who is having the balance as more than 500. Is it? So we have to find the probability of this region. Already we know the probability of your right hand side is 0.5. Is it? So 0.5, we can, in percentage we can write it as 50%. So option 2 is your right answer. Next we are going to see the next problem. So this is also an important problem. They have defined, just we are going to find, so this is nothing but the probability. Is it? What is given here is integral of 1 to infinity f of x dx. We are going to find the value for this. So this is nothing but probability of 1 less than x less than infinity. On seeing the problem itself, we can able to identify the mean is 1. The value of mean is 1, because what is the normal distribution? Density function is x minus mu the whole square. Here we can able to identify the value of mu is 1. So if you draw the normal distribution curve, they have given the mean value as 1. We have to find the probability when x is, that is we have to find that this is nothing but this is equal to probability of x greater than 1. So we have to find the probability for our right hand side. So this is equal nothing but the probability of our right hand side is 1. Since the total probability is 1, since it is symmetric, the right hand side is 0.5 as well as your left hand side is also, the probability of your left hand side is also 0.5. So 0.5, here it is 1 by 2. So your option 2 is your correct answer. So next we are going to see the next problem. What is the next problem is? Let x be a random variable following normal distribution. In this also they have given two variables, is it? So we are going to denote it as mu x and mu y as the mean of x and y. The mean of x is given as plus 1. So we are going to denote it as mu x is given as plus 1 and the variance is given. So sigma x square is given as 4. So if we need, we can find the standard deviation of x also. The standard deviation of x is 2. And what is given? They have given the y mean as minus 1 and we don't know the variance of the y variable, is it? Variance is unknown in variable y. So we know the mu y is given as minus 1 and sigma y square is unknown, and what we have to find is we have to find the standard deviation of y. Now we are going to find the standard deviation of y, but what is the one more condition they have given here is probability of x is less than or equal to 1 is equal to probability of y greater than or equal to 2. This condition is also given we are going to transform this normal distribution into standard normal distribution by assuming, that is, we are having two variables, so we are going to consider it as z1 and z2. How we are going to take the z1 as x minus mu x divided by sigma x, and we are going to define the z2 as y minus mu y by sigma y. We know the values of x. Here what is the value of the x they have given is as minus 1 and mu x as 1. So minus of minus 1, and what is the variance of the x is given as 2. So what is the value here in z1? The value is minus 1. Now we are going to evaluate z2. Y is given as, what is the y is 2. So 2 minus, what is the value of mu y is minus 1. So minus of minus 1 you will get plus 1 divided by, we don't know the variance of y. It is sigma y. Standard deviation is also unknown. Here in this problem we are going to calculate the standard deviation. So we have transferred the normal distribution. We have transferred the normal distribution into standard normal distribution. How we have transferred is, it is probability of z1 less than or equal to minus 1 is equal to probability of z2 greater than or equal to, what is the value we got there is 3 divided by, we don't know the standard deviation of y, so we will consider it as sigma y itself. Is it? Here. Now we have to find the value of that is, what is the probability of z less than or equal to minus 1. So in x distribution, what they have given it as the mean as 1. Is it? They have given the mean as 1. So if it is mu here, so this is your minus 1. If it is plus 1, so probability of z1 less than or equal to minus 1 is equal to probability of z1 greater than or equal to plus 1. By symmetric property, this two value will be equal. So instead of probability of z1 less than or equal to minus 1, we are going to write it as probability of z1 greater than or equal to 1. So which is equal to probability of z2 greater than or equal to 3 by sigma y. Now we are going to compare this two. It is 1 is equal to 3 by sigma y is nothing but standard deviation of y. So what is the standard deviation of y is 3. So in this problem we have to calculate the standard deviation of y. So the right answer is option 1. So the last problem we are going to see in normal distribution is, just we are going to find the value. So what is given here? On seeing this itself, we can able to identify the given is the standard normal distribution. Is it? What is the PDF of the standard normal distribution? We are transforming the normal distribution into standard normal distribution by substituting Z is equal to x minus mu by sigma. So if you substitute all this in the normal distribution probability density function, what is the probability density function of the standard normal distribution is f of z equal to 1 by square root of 2 pi e power minus z square divided by 2. Is it? So this is the probability density function of the standard normal distribution. Here what they are given, they ask you to find the value of this. So we know that the probability density, if it is given as the probability density function, the value of minus infinity to plus infinity f of x dx is equal to 1. So we are going to substitute this f of z in this. So here they have given it as, so we are going to, instead of x, we are going to write it as f z into dz. We are going to substitute the density function in the value. So we are going to substitute the value. So integral minus infinity to plus infinity. So 1 upon square root of 2 pi. Since it is a constant term, we can write it outside the integration. So 1 by square root of 2 pi e power minus z square divided by 2 into dz is equal to 1. But they ask you to find the value of square root of 2 pi. Is it? So instead of 1 by square root of 2 pi, they are given it as square root of 2 by pi. Just we are going to multiply 2 on both sides. I'll get 2 divided by square root of 2 pi integral minus infinity to plus infinity e power minus z square by 2 into dz is equal to 2. If you simplify this, your left hand side will become square root of 2 pi. So what is the value of this integral is 2. Option 3 is the correct answer. So in the next class, the next topic will be continued. Thank you.